Assalamualaikum and hi guys, Madam Jaswin here. So today pressure about pressure measurement, which is chapter 5. Right, let's start. So for the learning outcome, at the end of the chapter, students should be acquire the basic concept, terminology and principle of pressure measurement, and students should be able to identify the types of pressure measurement. Next, introduction. You always hear about pressure, right? So pressure means force per unit area. Okay, dah selalu sekolah lagi pada zaman sekolah lagi. So pressure exerted by a fluid on the surface of the container. So fluid can be either standard SI unit, Pascal, or Newton per meter square. English system we use PSI. Okay, so let's recall about what is absolute pressure, gauge pressure, and atmospheric pressure. Okay, so you can refer from this figure. Okay, P absolute equals to fluid pressure above the reference value of a perfect vacuum or the absolute zero pressure. Okay, and gauge pressure, P gauge. P gauge is pressure above the reference value of atmospheric pressure. So PATM here. Okay, so P gauge is pressure above the reference value of PATM. Okay. And what is PATM? At sea level is nearly 101 kPa or 760 mm of mercury. Pressure in the surrounding air. Okay. So next, video 1, I will give you the video link on the description of this video. So please have your time to watch the video. Okay.
Alright, I'm just going to talk a little bit about the difference between absolute pressure, gauge pressure, and vacuum pressure. So imagine we have all these things here at sea level. We have a house, we have your car, and we have this tank full of something, some gas or something. Alright, so what we do is first of all we say that we have a P atmosphere. And in thermodynamics and fluids, usually at sea level, we say that the atmospheric pressure is around 101 kilopascals. Now this is actually an absolute pressure. So we're going to say that this is ABS, just subscript ABS, and that just means that it's 101 kilopascals more pressure than a perfect vacuum, or more pressure than just a space full of nothing. For example, let's draw a little reference thing here. So if you imagine that, so if we say that this is zero pressure, we're going to say that, I can't write. We're going to say that this line is zero pressure, and we're going to say that their atmospheric pressure is going to be up at this level here, right? The pressure is going to increase as we go in the upward direction. So we're going to say that this is 101 kilopascals. So if you imagine something down here, this would literally be a perfect vacuum. So we have 101 kilopascals more than zero. So that's just absolute pressure. So we're going to say that this is equal to absolute. Okay, so now what happens is sometimes if you go, actually pretty much if anyone, if you just go look at your car tire outside, there's probably going to be a gauge on here, and if you're able to read that, it's probably going to say 32 psi. Okay, and this is also, if we wanted to convert this into SI units, just car tires are usually written in psi. This is the same thing as 220 kilopascals. Alright, now this is actually what we call a gauge pressure. So I'm going to write this here, gauge, or also sometimes you see PSIG. This means that this is 32 psi higher than the absolute pressure, and the absolute pressure is the atmospheric pressure that's all around it. Or also, yeah, so, or we'd have, 220 kilopascals more than 101 kilopascals. So if we wanted to write the absolute pressure of what's going on in this tire, well, the absolute pressure would just be, well, we can write this. We would say that P absolute is going to equal P gauge. Ooh, it's writing really slow. P gauge plus P atmospheric, right? So if we want to graph this on our little graph thing over here, well, we're going to have more pressure than just the atmospheric pressure of the absolute pressure of the atmosphere. And actually at this level, this will be, well, this is 200. You know what, let's write this down here. This will be equal to 220 plus 101. So this is equal to 321 kilopascals absolute. Right, so this 321 kilopascals more than our zero pressure reference. Okay, so we can write that here. 321 kPa. This is absolute. And then what we get in here is this difference. Well, 321 minus 101, that's going to be 220 kilopascals, 220 kPa, and that's what we said this. This is our gauge pressure. So gauge is just the difference from the absolute pressure to whatever pressure we're measuring. And in gauge, if it's positive, we call it gauge, and if it's negative, we're going to call that vacuum. So we're going to get to that in this tank. We say we have some tank here, and let's say that the absolute pressure in here is going to be equal to 81 kilopascals. So if we go put this on our reference here, we had 101, 321. This is obviously not a scale. Let's put this here. And this level here is going to be 81 kilopascals. And again, this is very, very not to scale, but that's okay. So this is, you know what, I can't even read that. kPa absolute, 81 absolute. So we want to find out what is the vacuum pressure in here. Well, similarly, same as gauge pressure, all we need to do is just, well, we'll have 101 minus 81. So this is going to give us 20 kilopascals gauge. Sorry, vacuum. What am I talking about? Vacuum. I suppose if you really wanted to, you could write negative 20 gauge, but they made a whole word for vacuum, so don't do that. You don't want to write negative 20 gauge. But if you want to think about it that way, I guess 20 kPa vacuum would be sort of the same thing as saying negative 20 gauge. But yeah, don't say that. Anyways, so yeah, there we go. So we have zero pressure. The absolute pressure is just how much more than a perfect vacuum we have. And then gauge pressure is how much more than the absolute we have. And vacuum pressure is how much less than the absolute pressure we have.
I'll explain to you about the differences between gauge, vacuum, and absolute pressure. Right? Next. Okay, method of pressure measurement difference depend on whether the pressure is more. Also depend on static or dynamic. Okay, so dynamic like those in reciprocating compressor or engines. And the accuracy of measurements is affected by the characteristic of electromechanical transducer on the fluid. Okay, so pressure higher than 1000 atm are considered very high, while pressure 1 mmHg or below considered as very low. Okay. And next, we move to classification of pressure measuring system. Okay, the most common pressure measuring systems are first, gravitational type pressure measuring system. So for the example, like manometers and piston gauge. Okay, so the second type is elastic type pressure measurement system. Okay, the example are Bourdon tube, pressure gauge, diaphragms, pressure gauge, bellows, strain gauge, and bulk modulus gauge. Okay, and next type are thermal conductivity gauge, like spironic type and thermocouple type. Okay, and the last one is ionization gauge. Okay, so please search at YouTube or Google on how measuring pipes looks like. Okay. So next, okay, the second video is on manometers. Okay, I'm sure you all have learned about manometer from subject fluid mechanics. Okay, so let's recall by watching the videos. Okay.
Manometer. A liquid is filled in a U-shaped tube. One limb is connected to a gas, the other limb is open. So, here are two limbs. One limb is exposed to the atmosphere, leaving it open. And the other limb is connected to a gas having gas pressure. We denote the atmospheric pressure as P and gas pressure as P0. If we have a careful look at this situation, we can say that the levels are equal. That means the pressure P is equal to the pressure P0. And in this case we can conclude this is a case of normal pressure. That means the gas pressure is equal to the atmospheric pressure. In this situation, as you can see, one limb is exposed to the atmosphere, the other connected to gas pressure. Again we denote atmospheric pressure as P and gas pressure as P0. And as we can see here in this situation, there is a level difference between these two. So we can say the pressure P0 is greater than the pressure P. And hence we can say the gas pressure is greater than the atmospheric pressure. That means this is a case of high gas pressure. In the third and the last situation, as we can see here, one end is exposed to the atmosphere, the other end is connected to some gas, and we can see the atmospheric pressure here is greater than the gas pressure. So we can say this is the case of low gas pressure. The gas pressure is basically less than the atmospheric pressure. So a manometer is used to compare the atmospheric pressure with gas pressure.
Okay, so we go to manometer's gravitational type. Okay, manometer is the simplest device for measuring static pressure. Okay, so simple U-tube manometer use water, mercury or any suitable fluid. Okay, the difference in H between the two limbs is an indication of the pressure difference, which is P1 minus P2 between the two limbs. Okay, so the formula, okay, you always see this formula. H equal to P1 minus P2 over rho G. Okay, so rho is the mass density of the liquid used in manometer. Okay, next, characteristic of a manometer fluid. We have three. So the first one is non-corrosive and not have any chemical reaction with the fluid which pressure is being measured. And B is low viscosity to ensure quick response to pressure change. Okay, and should have negligible surface tension and capillary effects. Okay, so we move to the formula. So we discussed just now. So we have equation P equals to rho GH and P1 minus P2 equals to rho GH. Okay, where rho is the density, G is the gravitational force, and H is the height difference. Okay, and SG, okay, is the specific gravity of the substance, where Sg equals to rho of substance, okay, divided by rho G H2O. Okay, so this is the example of the question about this manometer. Okay, so U-tube manometer containing a mercury specific gravity 13.6 as a working fluid is connected to a tank which contains air as shown in figure. The other end of the manometer is exposed to the atmosphere. Determine the pressure in the tank if the atmospheric pressure is 100 kilopascal. Neglect the air density and given H equals to 0.4 and So what you need to do, you can use your knowledge from fluid mechanics to answer this question. Okay, so I will give you the example how to do this question later. Okay, but I hope you can try it first. Okay, still use the same formula with fluid mechanics. Okay. Okay, next the other question. Okay, also please try. Okay, I will give you the contoh pengiraan later. Okay, so next, other types of manometer. Okay, Chilston or well type manometer. Okay, this is the example. And then inclined tube manometer, micrometer type manometer, movable tube type manometer, and micromanometer with motor drive and digital readout. Okay, so this is the example of the manometer, the micromanometer. Okay, right? So you can also search on how they work. Okay, so next we move to Borden tube elastic type. Okay, so it selalunya okay, untuk elastic type ni dia akan the keywords is deformation. Okay, so when pressure applied, the elastic elements will get deformed. Okay, based on this deformation, the pressure can be measured. Okay, deflection, tetap dia deflection, dia ada displacement. Okay, kan ada X. So the deformation may be measured mechanically or electrically. The elastic elements are as follows. Okay, the first one is diaphragm. Okay, the pressure is from below. Next, bellows. Okay, and corrugated diaphragm. C, capsule. Next, Borden tube, and F is helical tube. Okay, next is the video for bellow pressure gauge and also video for diaphragm pressure gauge animation. Okay, please watch both video.
Bellow pressure gauge. Do you know how we can measure the pressure of flow of water in a peaceful river? Actually, there are many instruments by which we can measure the pressure of flow. One of the instruments that we can use to measure the pressure of flow is bellow pressure gauge. Now let's see the working of bellow pressure gauge in the animation. As we start the water supply in the pipeline, the water strikes the tubular membranes known as bellow. Then the pressure to be measured is applied outside the bellows. A bellow gauge contains an elastic element, that is spring, that is a convoluted unit that expands and contracts axially with changes in pressure. The spring in bellows gauges is made of brass, phosphor bronze, stainless steel, or other metal that is suitable for the intended purpose of the gauge. The movement of the bellows can be converted into linear displacement. This displacement can be converted in terms of pressure. As flow of pressure increases, a pointer starts rotating on the dial, which indicates the pressure of the flow. And to make this measurement precise, the scale of the dial is divided in many sectors. After some time, the pointer assumes a new position on the pressure calibrated scale on the dial to indicate the applied pressure directly, and thus pressure is measured on the dial.
Pressure measurement. Diaphragms. A diaphragm is a stiff corrugated disc which is flexible under pressure. A single diaphragm is often used as a seal to protect a gauge from corrosive liquid. A typical example is given in the illustration. Okay, so this is the example of metallic diaphragm gauge. Okay, the diaphragm is located here. Okay, so when pressure is applied, the corrugated diaphragm will deform. Right, so when it deforms, it will activate the hairspring pivot, so it will give the reading at the scale. Right, so next, Borden gauge common being used to measure pressure. Main element of Borden gauge is elastic Borden tube. Okay, we have learned about this Borden tube in chapter 2 before this. Okay, so this is the elastic Borden tube. The pressure being measured by amplified the motion of the tube end and indicated by a moving pointer on a calibrated scale. Okay, so this tube end will activate the pivot and spring, so we'll give the reading. Right, so next we move to high pressure measurement. Special techniques have to be used for measure the pressure above 1000 atm. The technique based on the electrical resistance change of a manganese, okay, alloy of copper, nickel and manganese, or gold chrome wire with hydrostatic pressure to accommodate a bulk compression effect. Okay, so this is the high wire pressure transducer. So pressure wire insulators from A and B. Okay, the core is enclosed in a flexible bellows filled with kerosene, medium of transmitting pressure to the coil. Change in resistance of the wire between A and B is measured by usual method like Wheatstone bridge. Okay, so as you know, Wheatstone bridge is used to measure very low values of resistance. Okay, so next video is about hydrostatic pressure gauge. Okay, so hydrostatic pressure gauge is to measure high pressure. Okay, so let's go together how the working principle. The hydrostatic pressure created by a liquid is directly related to the height of the liquid column. Okay, so you know pressure equals to rho GH. A pressure gauge is installed at the bottom or on the side of the tank containing the liquid. The rise and fall of the liquid level causes a corresponding increase or decrease in the pressure P, which is directly proportional to the liquid level H. Right? The dial or scale of the pressure gauge is calibrated in the units of level of measurement. This gauge functions smoothly when the liquids are clean and non-corrosive. Okay, but for corrosive liquid with solid suspension, diagrams sealed between the fluid and the pressure gauge are generally employed. So let's watch how this hydrostatic pressure gauge works.
of the medium. In an open tank, pressure is continually compensated in relation to ambient air. Therefore, the gas in the upper area of the tank does not affect level measurement. However, in addition to the pressure of the liquid column, the atmospheric pressure also acts on the sensor. In atmospheric pressure compensation, the sensor is called a gauge pressure sensor. Let's have a closer look at such a sensor. The Contite measuring cell is based on silicon technology and has been particularly developed for hydrostatic level measurement. Resistances are applied to a silicon chip in form of a Whetstone bridge. As pressure is applied, the process diaphragm is deformed and a change in resistance results. In the sensor, incompressible oil transmits the pressure from the process diaphragm to a silicon chip.
Right, next we move to low pressure or vacuum measurement. Okay, so vacuum measurement are represented by unit, torr and micron. Okay, 1 torr is a pressure equivalent of 1 mm of Hg, while 1 micron is 10 to power negative 3 torr. Okay, so manometer and elastic element gauge can be used to about 0.1 torr. Below that range, vacuum gauge are needed. Okay, so there are 4 examples of vacuum gauge written here, which are first is MEC322 gauge. Okay, second is thermal conductivity gauge or Pyrenees gauge, and ionization gauge, and also Knudsen gauge. Okay, so you guys can search more info about this vacuum gauge, okay, from the internet. Right? Okay, next. So next is the range of pressure measuring device. So from this table we can see the pressure range for each type of measuring device. Okay, for example, manometer from 10 to 10 to power of 6 Pascal, from high pressure to vacuum or low pressure. For example, Knudsen gauge, so very low pressure, 10 to power negative 8 to 10 to power negative 2 torr. Okay, so references. Okay, so that's all for this chapter. I hope you guys can understand how to measure the pressure. Okay, what type of instrumentation that measure the pressure. Okay, thank you for watching. Good luck and Assalamualaikum.